In this video I am going to show you how to compile the main program. There are two stages of the compilation process. One is for the compilation of the shaders, which will be done by the command compile.sh. This is the file that we used for compilation, which includes the command for each shader file for each graphic object. And for each graphic object there will be a vertex shader, geometric shader and fragment shader. We need the compile format .spv in order to run the main program. Next thing is I am going to generate the executable for the main program, which I use the command make all. Now it is going to build an executable called Cuda marching cube. If you check the make file, you can see the build is it is going to build the Cuda marching cube executable. It will be come in this place after the compilation completes. Now it is compiling. Just wait for that. Now the compilation end, we can see the executable here, and I am going to execute the command. Enter the grid dimension value. Here you can enter any value between 8 and 32. That is a minimum and maximum value that I set in this program. You can change based on your computation power. I am entering the value 16. Now we are going to see the real-time topology optimization. It is happening in real time, the three kind of physics happening and two kind of optimization process. One is in the top left is structural topology optimization, and the bottom left you can see the thermal topology optimization, and the top right corner you can see the fluid simulation happening in real time. There is no optimization in the fluid simulation. And in the bottom right I left the space there. What my plan is to generate the final geometry which is based on these three physics. I will do those work in the next stages. Right now I am just showing these three different physics, and in the end after the 50th iteration the result will be generated. This is corresponding to the 50th iteration for the structural analysis or the structural topology optimization. The file is written in the OBJ format. For thermal analysis, the file just generated in the OBJ format. So two outputs of the simulation we can export into any other CAD packages that support .obj format. So I am going to visualize this in the mesh lab just to check if there is any error. So import mesh. This is the file we have generated now. So I am just checking if there is any error for this file. Look like it is a good file. We can straightly go to the Cura slicer. We can import this structure. We can check whether it will be good for slicing. So we can open both structural optimization result file as well as the thermal optimization result file and check whether it is able to generate the sliced format. So it is looks like it is okay. I'm just magnifying. I'm not checking the orientation now, just to prove whether it is good for slicing. So it is okay with that. The file structure is okay for slicing. So just wait, it is slicing, you can see. In the meantime we can open the thermal analysis result in the mesh lab. Just check for any error. This is the file we have generated in the thermal analysis. Is there any error? Look like it is also a good file, so you are good to go for the slicing process. Preview for the sliced one, which is the structural analysis. So we can see it's a good file. Display, this is the layer that will go. Stop this, delete the file, import the open files, the thermal. It's a small file. We are going to magnify this. Let's see. Outline type, layer view. Let's slice this. So it is also a good file to slice. Let's see what happens in the end. It is slicing. So just preview the slicing path, sliced path or tool path. This is the result. As we can see, it is good for the manufacturing process. So I am stopping here. I will update with the result of the final geometry based on the 3 different physics in the next stages. Alright, thank you for watching.